Since the object is on a surface, it has the normal force. We know that all objects near the surface of the Earth also have the force of gravity. The force of gravity is not in the x or y plane, so we need to break it up into its horizontal and vertical components. FGY and FGX. Then we determine if there are any other forces acting on the object. Because it tells us there is an applied force and it's being pulled up a hill, we draw an arrow going up the hill in the x direction for the applied force. We know there's friction because of the coefficient of friction. We know that friction goes the opposite direction of motion, so therefore we draw an arrow going down the hill for friction. Once you complete the free body diagram, then you can write your net force equations. Because we know the object is accelerating in the plane of the hill, we represent that as the x direction. Whenever an object is accelerating, we set the net force equal to ma. This represents Newton's second law. Because the object is not accelerating or even moving in the y direction, we know that the net force in the y direction is equal to 0. It is in equilibrium in the y plane, which represents Newton's first law. After we write our net force equations, we then break it down and substitute the forces that exist in each plane. In the x direction, we have 3 forces. So for our net force equation in the x direction, we write them accordingly. Now I'm going to make the plus and negative a subtraction already. In the y direction, we know we have 2 forces, Fn and Fgy. Now we can continue to solve for the appropriate force. I'm going to start with the y side and get Fn by itself. I know I'm going to need this because there's friction involved. I'm now going to substitute the equation for Fgy. I use the cosine because Fgy is the adjacent side to the angle. In the x direction, I know I need to solve for the applied force, so I'm going to get the applied force by itself. Now I'm going to substitute equations that I know for any given variable, such as the friction and the Fgx. From here, I'm going to plug in numbers. I'm going to round to the nearest tenths place. Now that I have the normal force, I can solve in the x direction. Now I'm going to simplify. And then add. That's our final answer. I hope this helps.